Okay, this is Unit 3, Lesson 6 and 7 in Connexus, second semester, 7th grade math. Okay, so vocabulary review. Percent, like Atisha said, means per 100. Cent, think about the root word, or century. How many years in a century? Just to kind of think about that. Per 100. How many are there per 100 of them? Okay, or out of 100, how many would there be? Change each percent to a decimal. How do we do this? Do you guys remember how to do this? So this is review. We know how to go from a decimal to a percent and a percent to a decimal, but they're just wanting us to go from a percent to a decimal. How do we do this? Alexis? We move the decimal twice to the left. And now 2, 3, and 4 are all without a decimal, but we know where the decimal goes. Where is the decimal? On the right-hand side. Very good. So if I was to rewrite 4% with the decimal, it would be right here. Okay? Now we have to move it 2 to the left, 2 places to the left, like you said. Do you remember what we call that if we don't have enough digits? We have to put some digits there. Do you remember what they call that? We got to annex some zeros, right? So we're going to put some zeros, and then we're going to move my decimal 2 places to the left. 1, 2. And then, what is the answer? What do we call that number once we've moved it 2 places to the left? It's going to be, I'll write it out. What is it? 400ths, because tenths and the 4 is in the hundreds place, so it's 400ths. Okay, are we good? This is very important for what we're doing today. Okay, so for number 3, who can walk me through number 3? Who's got the answer for number 3? Chin, what's the answer for number 3? Very good, it's 900ths. So if we have 9%, we know where our decimal is, so this is very similar to Alexis's problem. Alexis. And we're going to move our decimal 2 places to the left. 1, 2. And that gives me 0, 900ths. Okay, any question? Are we good? Tomorrow, I'm probably going to let you guys use calculators, and you're going to see why I'm going to let you use calculators. Number 4, 20%. How do I rewrite 20%? Gabby? 2000ths, we could say 2000ths. So that's not incorrect. There's my decimal. I would have to annex 1 0. Moving my decimal 2 places, this is what we get, 0. So that's not really incorrect. If all we have are zeros to the right of my last non-zero number, in this case 2, I can also just say 2/10 and get rid of that 0. 2/10 is the same as 2000ths. Okay? Okay, and who would like to get my last problem, number 5? Somebody I haven't heard from yet would be nice. Marcellus, could you tell me where my decimal is going to be, or what's the number going to be? Can you name the digits in order for me? So, do you remember what Alexis said? How many places we're going to move my decimal? Can you remind him, Alexis, how many places we move our decimal and which direction? Which direction? To the left 2 times, right? So here's what we got. Now this problem is a little different than the other ones, right? Because we already have the decimal there, right? Okay. So before I go moving my decimal, I got to annex some zeros. So how many zeros am I going to put in here?
1.
We could put 1. Let's try 1. And if I move it, you said 2 places, 1, 2. That's where it would end up, right? So 1 will get you by, but when we write my answer, we're going to need to put 2 there. Okay, and what number is that? So the first number to the right of the decimal is the tenths, hundredths, and what's the place of the 5? Can you help them out? What's the place of the 5 here? No, that's a decimal here. That's tenths, hundredths, and then what's that place? thousands. So the way we'd say this, the number, I'm trying to get you guys, refresh your memory because we got the part coming up. It's 65 thousandths. Got it? Okay, any questions? All right, moving on. So let's talk about this, what you'll learn. To find simple interest and compound interest. New vocabulary: principal, simple interest, compound interest, and balance. All right, why learn this? Money may not grow on trees, but it can grow in a bank. When you deposit money, you earn money called interest. When you borrow money, you pay interest on your loan. So if you borrow money, you pay a fee on top of what you borrowed while you're borrowing it, okay, until you pay it off. If you leave money in a bank, you can get paid for leaving it in the bank. That's called a savings account. It's an interest-bearing account. Okay. Most checking accounts don't have, you can't earn interest on that because they expect you to be spending and using that account to make purchases. Does that make sense? But a savings account, if you leave money in a savings account, the interest rate will be calculated and they'll add to what you leave in there. Does that make sense? Okay. Now, the bank isn't going to pay you as much in interest as you would pay them to borrow money. Does that make sense? So, we're going to make some calculations so you can see exactly how this works. All right. The original amount you deposit or borrow is the principal. Okay? The interest earned only on the principal is simple interest. Okay? Know the definition of simple interest. The interest earned only on the principal is simple interest. That's very different than what we're going to talk about later. There's another type of interest called compound interest, but we're just talking about what interest do we get only for the principal. Okay, that's called simple interest. All right, so here's the formula. Take a look. Simple interest formula. I have I for interest. P, I chose green on purpose. Why do you think I chose green? That's the money we put in. Got it? Or the money that we're borrowing. Principal, I have it in green here. R is the rate, okay? And the rate is based upon a percentage. But we don't work with percents. We work with decimals. So when they give you a percentage rate, you need to rewrite it as a decimal. So do you guys understand why we had the warm-up? Does that make sense? Okay. And then T, that's how much time passed in years. Got it? So that's the amount of time that will pass in a year. Okay? So find simple interest. Take a look at this. I give you the formula, and I'm going to work this out with you. So if you have $300, if you borrow $300 for 5 years at an annual interest rate of 4%, what is the simple interest you would pay in dollars? Okay? Let's go ahead and enter into our formula what's going on. Okay? So to me, the hardest part is just knowing what goes into what part of the formula. So what do I put in for principal? 300. That's the amount I'm borrowing. Okay, and then I got to multiply that by my rate. And what's my rate going to be? It needs to be as a decimal. 4%. I need to write that as a decimal. 400ths. Very good. Okay. And then how much time is going to pass? 5 years. Okay. So let's go ahead and calculate that out. Can you guys quickly multiply that? Okay, what do we have? Who has the answer? Go ahead, Noah.
The answer I came up with was $60.
$60? Is that what you guys got?
Yeah.
So the interest is $60. Now be careful when you're writing this out, because when we're talking about money, if we have a decimal value, make sure that you carry it out to the hundreds place, because we need to make sure that we're going to the nearest penny. Does that make sense? So $60, if you just had $60 and there's no pennies, I'll take that. But if you have parts of a dollar, make sure you have it to the correct decimal place. I have said this before. You guys remember this in the past? Make sure you're using the appropriate number of place values. Okay, so pretty easy. So here's what this says is, if you borrow $300, by the time you pay it back in 5 years, you'll have paid how much? $360 back to the bank. So do you see how the bank makes money by charging you a little bit more than what you borrow? Does that make sense? Okay. And that rate is important. So 4%, that's actually a pretty low rate. Credit cards, the rate's really, really high. That's why you have to be careful when you use your credit card to buy things. All right, so let's go ahead and calculate the simple interest for this problem. If you guys can, I'll read it to you. I want you guys to calculate the simple interest you pay on a $220 loan at 5% annual interest rate for 4 years. Calculate what your interest would be. This is just the fee you would be charged for borrowing that amount for that time. When you're done, if you could put your pencils down. So I still see a few people writing. I'm going to go ahead and fill in the formula. Chin, what do you got? Is that what you guys got? Yeah. Did somebody get something different? $44. Okay, shh. So that is what you'd pay. That's what you'd owe the bank on top of the $220 that you borrowed. Does that make sense? So in the end, how much are we paying to the bank? $264. So I'm trying to emphasize this because we're going to see in a moment a different formula. So this is the interest based upon only the principal, the part that you borrowed. Got it? Okay, that's simple interest. Now, I want you to understand how we go about graphing simple interest. Okay, so this ties in with what we did before. A graph can show the increase in interest earned over time. You have $500 in an account that earns an annual rate of 5 1/10%. At the end of each year, you withdraw the interest you have earned. Graph the total interest you earn after 1, 2, 3, and 4 years. So after a year, how much interest did you earn? Did anybody get that yet? Looks like most of you still writing. There's a handful that are ready to go. Okay, so now this is kind of the opposite of what the problems we did earlier. This is, I'm leaving my money at a bank, and they're going to pay me interest. How much am I going to get after a year if I leave $500 in my interest-bearing account? Robert, I don't think I've heard from you today. What is it? And that's what I'm talking about. We don't want to say 25.50. We're talking about money. $25.50. Okay? So in 2 years, how much is that going to be? In 2 years, it's $51. In 3 years, it's going to be what?
$76, yeah.
Okay. And then in 3 years, how much we got?
102.
It's going to be a 102. Okay. So let's go ahead and quiet, please. Let's go ahead and graph these because you're going to see that on the quiz tomorrow too, knowing how to graph a table. Now, if you notice, what type of sequence do we have here? It's an arithmetic. Does it go through 0, 0? If I have a time of 0, would that mean it goes through 0, 0? Yeah, so that means we have a geometric and arithmetic sequence, right, for our outputs, right? And it would be, what type of relationship are we going to have when we graph it? It's going to be a positive, but what do we call that graph when we draw the line through everything? A linear relationship. So quiet, please. I'm going to go ahead and graph this. There's way too many side conversations going on. You need to make sure you know how to do this for tomorrow. So at 1 year, we're just over a little bit over 25. In 2 years, we're about 50, just a little bit over 50, about 51. 3, it's 75, just a little bit over 75. And then at 4, we're about 102. So if I was to draw a line through this, representing my interest, it would be a linear relationship. Okay? All right, so a little bit of review. Now what I need you guys to do, on your own, we're doing the same thing. Sketch your graph. It doesn't have to be a perfect graph, but definitely sketch your graph. You should have your T-chart. Label your first column and your second column of your T-chart. Who can tell me what my decimal is going to be for my interest rate? Michaela? Can you use the correct name for it? This is review. I'm trying to get you guys ready for this. Naming these decimal numbers. Let's go ahead and I'll write out what you said and see if we can remember. Okay? You said 0.042. What is the name of that number? What'd you say? I'm sorry, if I didn't hear, I apologize. 42 thousandths. 0 and 2 is in the thousands place, 42 thousandths. Okay, and then how much year is going to pass for our first one's 1 year? All right, so if you want to calculate 4 years, it's easier just to do the 1 year for simple interest and then use the common difference, right? So what does that end up being? Did anybody get that yet?
I did.
Bryce, haven't heard from you yet. Go ahead. Did you guys get the same thing? Very good. $39.90. Okay. Now, make sure you know how to graph these. What's it going to be in 2 years? Bryce, go ahead. What's it going to be in 2 years? Very good. $79.80. And then 3 years? $119.70. Okay. And then 4 years, what do we got? $159.60. Okay, I'm going to go ahead and graph this. And again, we should get a linear relationship. So in 1 year, we got $39, almost $40 in interest. Okay, so I'm going to put that right about here. Okay, and then in 2 years, we have almost $80, right? So halfway between 50 and 175, so a little bit above the halfway point between 50 and 100. I'm going to say that's about 80. And then in 3 years, we have almost $120. So this is 100. That'd be 125 halfway up, so just below that. Okay, and then the last one, 160 in 4 years. So here's 150. Halfway between 150 and 200 be 175, so a little bit lower than that. Okay, if we drew our line connecting these points, we get, again, a linear relationship. Okay, any questions? Yep.
What happens if you don't get a linear relationship?
For this, you will.
And if you don't?
Then you might double check your graphing. Okay. All right. Any questions? So for simple interest, you will if you're just calculating what the interest would be for each year. Now I want to talk about compound interest, and because we're going to be raising to an exponent, and the exponent could be larger than 2. I think I'm going to have to look at the quiz and figure out if the exponent is going to be a number of years where I might just let you guys use your calculator tomorrow. But let's take a look what compound interest is. Now, simple interest is just the interest you earned for the principal. Compound interest is a little bit different. So compound interest is the interest that is paid on the principal, what you put in, plus any interest that you leave there as it stays there. Does that make sense? So every year you get for any duration of time that you leave the money in a bank, you earn interest if you don't pull it out. Does that make sense? If I don't pull out the interest, then I have a new balance. Does that make sense? I get whatever my principal was plus the interest they paid me. Do you understand? So if I leave that in there, now I have a balance that's growing. Does that make sense? So I'll read it again. Compound interest is the interest that is paid on the original principal and on any interest that has been left in the account. The balance of an account is the principal plus the interest. Okay? So remember when I was asking the earlier problems and say, hey, what did you pay back to the bank? You got to take the interest and then add it back to the principal. Okay, well, this formula is a little different. This formula gives you the principal plus the interest together. Okay? So if the question asks you for the interest, you got to think about what you've just calculated. So key concept, compound interest formula. The balance, now the balance is the principal plus the interest. Got it? And here's the formula. It's the principal multiplied by 1 plus the rate raised to the exponent of t, which is time in years. Okay, let me work out a problem for you. All right, I left P green for the principal. Rate, I still kept the same color for rate. Now here, you deposit $5,000 into a bank account. Okay? That account pays 3 7/75% compound interest. Okay? So, this part right here, 1 is always going to be there. The R is whatever my rate is. In this case, I need to rewrite that as a decimal. What's 3 7/75 as a decimal? How do we say that number? Somebody said it. 375 10,000ths. Okay? And then my time is the exponent. In this case, the exponent is a 9. So now, for this formula, you have to make sure you do things in the correct order. Remember order of operations? I got to take care of what's in the parentheses first. So if I simplify what's in the parentheses first, what do I get back?
1, 1, 3, 3.
Well, you guys know how to line up your decimal, right?
Yep.
My decimal on the 1 would be right here. So if I was to add these two together, here's what I get. 1. And then we got to raise that to the 9th power. Do you guys see why I'm probably going to let you use a calculator for a problem like that?
Yes.
Okay. You'd have to keep multiplying, and that's a lot of decimals you're multiplying out. So, and then now you probably understand why I showed you how to calculate any base to any exponent. Remember the x to the y? Do you guys remember that? So I would enter my base, which is 1 and 375 10,000ths, and then I'd have to use the x to the y button, because now I told it what the x is. Now I got to tell the y, and what's the y going to be? The exponent? It's going to be the 9, right? And then I would hit enter or equals as soon as I did that. Now I'm going to tell you what that number is, and I want you to calculate this last part. So when I calculated this, here's what I got, and I'm just going to, this gives me a really long decimal number, and it actually, I'm going to round it to the nearest 10,000ths place. And here's what I get. Can you guys go ahead and calculate that? And then we'll know what the balance is. So in 9 years, you left $5,000 in your savings account. What would you have in that balance? What would you have in that account if you showed up 9 years later? Miranda. Very good. So after 9 years, you'd have $6,964. $6,964. Okay? So that doesn't answer the question on that I want to ask you. How much interest did you get from the bank leaving that $5,000 in there? How much interest did you get? How are we going to figure out how much interest we got? Be ready for this on the quiz. You're going to take 5,000 and you're going to subtract it from the balance so that you know how much the bank paid you for your money sitting there. So in this case, what's it going to be? That would be your interest. Okay? That would be how much you got from the bank, leaving it there for 9 years. Compounded interest. Okay? And I'll put a little C here because this is not simple interest, this is compounded interest. Yep?
So when you're going to let us use calculators?
I gotta look and see what the questions ask, because I think if they want to know how much interest you have in 10 years, I don't think I'm gonna have you guys calculate that. I'm gonna let you guys see the calculator. I gotta double check. Take a look over here. Next problem. Let's go ahead and do this one. We're almost done. Almost done. Does anybody have a question? I'll go ahead and read this to you. You deposit $3,000 in a bank account that pays 4 and 2/500% compound interest. What is your balance after 12 years? What I'd like for you guys to do is just set it up.
Oh, great.
What's my principal?
3,000.
$3,000. Okay. Now I got to multiply by that 1 plus what my rate is. And can somebody tell me what my rate is going to be?
425.
Right. 425 10,000s. And then what did I just leave out? 12. And what it's got to be the exponent 12, right? Okay. So you guys need to simplify what's in the parentheses. And what happens when I simplify what's in the parentheses? I get 1. Okay, and I got to raise that to the 12th power. Let me go ahead and tell you guys what that's going to be. So I have my base. I'm going to enter the base in. 1 and 425 10,000s. And I got to hit the x to the y button because now I got to tell it what my exponent y is going to be. I just told it what x is. You guys remember that? Okay. Trying to make sure you guys are good for tomorrow. And then I'm going to push 12 in. And once I hit enter, I just told it what my exponent is going to be. So here's what I get back. And I'm going to keep it to the same decimal place value in the parentheses. So I'm out 4 places here. So here's what I get back. Okay, so when I simplify it, here's what I got. Yep. Take a guess. It's okay. We don't want to mix up again, but you might have it. Go ahead. What's it going to be?
For the like the very, very, very final answer.
Yeah, what do you think?
I got 153. No, like for.
Oh, you're talking about like the interest only? No, I think you didn't carry some things. Let's try to get that fixed. Jaden, can you tell me how much is my balance going to be first of all?
I got 4,943.
Very good. $4,943, and you should have got 40 cents. Okay, is that what you guys got?
Yep.
Okay, so if I take that amount, I can calculate my interest earned during that period, right? So can you tell me what the interest is that we earn? And I'm just trying to get you guys ready for the question that you're going to probably see in Connexus. So they gave you the balance, but we want to know how much interest did you get during that period?
1,933 and 40 cents. I said 33. There's 33 up there.
This is compound interest. Okay, that's how much you got on top of the $3,000 that you earned. Oh, I have a typo. That should be sorry about that. 40, here, let me fix it. That should be a 4, so this right here should be a 4. All right, thank you. All right, now we're almost finished. Who can tell me, how do simple interest and compound interest differ? So think about the formula for simple interest and what's going on there, and then what's going on with compound interest. And actually, the book gave you the definition of the two to try to get you to understand the difference. Who can explain to the class what is the difference between the two? Noah, go ahead.
Alright, when you're doing simple interest, after you get the total, after working out your problem, you usually add all the stuff up to get your final answer. Depends on
Oh.
how much you're getting
Not quite what I was looking for. Can somebody help him out? Jaden, go ahead.
Compound interest is how much the bank gives you over a period of time.
No, not quite. Miranda?
Okay, so compound interest is the interest that is paid on the original principal, while simple interest is the interest earned on the
Okay, you're close. Simple interest is just, I'm going to tell you where we slipped up. You left one small piece out, but that's like the important piece. I want you to listen to what I'm going to tell you. So simple interest is the interest you earn just on the principal. Got it? Compound interest is the interest you earn on the principal plus interest that builds up over time. Does that make sense?
Yep.
Do you guys understand the difference? Okay. So as you leave something in an account that's compound interest, a compound interest-bearing account, what happens is the money gives you a little bit over time that you leave it in the account, but then you have a new balance to recount. Does that make sense? Okay, so simple interest is just calculated on the principal, but compound interest is calculated on the principal and interest that's earned over time in the account. Does that make sense? Now the formulas are also different. Simple interest gives you the actual interest amount you get for the principal, right? Compound interest gives you the balance, so it gives you what you put in there to start with, plus the interest that you get for having it stay in that account for that time. Does that make sense? So find the simple interest, and we're gonna see how they're different. Find the simple interest earned on $2,000 at 10% for 6 years. Find the interest earned for $2,000 at 10%. Who can tell me the formula for interest? Who knows? Who remembers it? Wait. Can I get one person to volunteer? Because I got a bunch of people yelling out. Can I get one person to volunteer? Joel, what's the formula? Very good. It's principal multiplied by the rate multiplied by time. Okay? So, can you guys go ahead and calculate that? Now, many of you might have been able to calculate this mentally. What did you get? What's 10% of 2,000? It's 200, right? Because 10% of 1,000 is 100. So 10% of 2,000 is 200. And then what's 200 times 6? Okay, so that is the interest that you would earn. That's the simple interest you'd earn after 6 years. Okay, now if you had an account that gave you compound interest, how do we figure that out? Let's go ahead, set it up, and for 6 years, I would have you guys go ahead and use a calculator for this problem. But what we're going to do is we're going to figure out how these two are different. Okay, make sure you know what you're simplifying and the order of operations. So here's what we got. And this part right here, I would expect you guys just to use your calculator for this portion right here. So 1 1/10 raised to the 6th power, I'll tell you what that's going to be. Here's what we get back. And I will just go to the nearest tenths, okay? Nearest tenths. And so when I multiply that out, this is what I get back. Who's got it? What'd you get? 36,000. Okay, so that's different though. That's not the interest. How would I figure out the interest I earn using compound interest? I would take that and find the difference of that with 2,000. And what would that end up being? 1,600. And this is compound interest. Okay? And so look, do you see the difference between what you'd earn for simple interest and compound interest? There's a difference. Do you guys understand the difference between the two formulas? Now, something I want you guys to take a look. True or false? Doubling the principal will double the balance. Will doubling the principal double the balance? Look, if this part doesn't change and I double the principal, will it double the balance? That is true. Okay, in the